Today we are going to understand the, the calculation of uncertainty in a measurement. So today the topic is how will we calculate the uncertainty in a measurement. The first thing that we need to understand is that what is the basic principle. Let's suppose you're given with two numbers x and b. Number x is 10 plus minus 1 and a number y is 5 plus minus 2. Let's suppose these are the values and uncertainties of x and y. Now you have to calculate another number z that is equal to x plus y. Now we have to calculate a number z that is equal to x plus y. What is the method to calculate z? Now this question is about calculation of a third quantity from two quantities which are given along with their uncertainties. Now what would be the steps? You need to calculate the maximum possible value of z. Then you need to calculate the minimum possible value of z, and then the uncertainty in z will be equal to uncertainty in z will be equal to z maximum minus z minimum whole over 2. So uncertainty in z will be equal to the maximum value of z minus the minimum value of z and over 2. Now let's solve this question with this example. In this example, x can be written as minimum, average and maximum. Generally the quantities are given as a range. The value that we state is the average, and the range is given as minimum to maximum. Now for x, the minimum value is 9, the maximum value is 11, and the average value is 10. So these are the values for x. Now for y, values of y will be, the minimum value will be, it would be, you see, minimum value, average value, and then we have maximum value. Minimum value is 3, average value is 5, and the maximum value is 7. Now first of all, if you want to calculate the minimum value of z, z minimum would be equal to x minimum plus y minimum. If x and y both are minimum, then z will also be minimum. So minimum value of z will be equal to, you see, x minimum is 9 and y minimum is 3. So the answer would be 12. So minimum value of z is 12. Now let's calculate z maximum. Z maximum would be equal to, you see, x maximum plus y maximum. Now x maximum is 11 and y maximum is 7, so it would be 18. Now we have the minimum value of z and the maximum value of z. The minimum value of z was, you see, it was 12. The maximum value of z was, as you see, it was 18. So maximum z is 18, minimum z is 12. Now let's calculate uncertainty in z. Uncertainty in z would be equal to the maximum value of z minus the minimum value of z whole over 2. So the uncertainty in z would be equal to 18 minus 12 whole over 2. And one thing, since it is random uncertainty, so it will go with plus minus. Since it is random uncertainty, so it will go with plus minus. It would become plus minus 6 over 2. And 6 over 2 will become 3. So plus minus 3. So this was calculation of uncertainty in Z. If I explain this concept on a graph, then you need to understand that the quantity Z, you will assume Z to be symmetric in the given range of minimum to maximum. And this is Z average. This is Z average. So Z average is in the center. If we calculate Z average, it would be 15. Now, this is Z average. If we mark uncertainty on this drawing, then it would be, this is delta Z. Or you can say that this is delta Z. And delta Z is the uncertainty. As you see, delta Z on both the sides is equal to the half of the range. What is the range? The difference between minimum and maximum is called the range. If you make the range half, then it is the uncertainty. Just for example, from this point to this point, it is the range of Z. Range of Z is basically Z maximum minus Z minimum. Now the concept is half of the range represents the uncertainty. So when you go for a measurement, in case of addition, subtraction, multiplication or power, then the uncertainty is half of the range of values. Now, this is a simple method of calculation for uncertainty. But sometimes, sometimes you will get a situation when this method will not work. Let's suppose we understand a situation. You are given with a rectangle. You are given with a rectangle. Now, there are two situations, and what is the difference between the two situations? You have to observe that. Here, width is 5 plus minus 1. The length is 9 plus minus 2. Here, the situation is uncertainty in length, that is delta L is plus minus 0.5. uncertainty in width delta L is plus minus 0.7. Now you have two questions, and the difference between two questions is that in one of the questions you are given with values along with uncertainties, while in the other question you are only given with uncertainties delta L and delta W. This is the difference. They are two questions with different data values. However, the situation is same, but the style of the values which are given is different. In one example, values are given in a different way. In the second example, the values are given in a different way. Now, in the first part, if you calculate the maximum width and the minimum width, the maximum possible width of this rectangle could be 6. The minimum possible width could be 4. In the same manner, the maximum possible length could be 11. The minimum possible length could be, how we get 11? 9 plus 2. And minimum would be 7, that is 9 minus 2. So in this part, we are able to find the maximum and minimum value of length and width. Now we are able to calculate, let's suppose the question is calculate uncertainty in area. Calculate uncertainty in area. Now by principle that we have understood today, the uncertainty in area would be maximum area minus minimum area whole over 2. And in this question, we can apply this formula because the maximum value of area and minimum value of area both are given. Now let's go to the second situation. Here you see the uncertainties are given, but the values are missing. So in this situation, you see you cannot find L maximum or L minimum. Here you cannot find the maximum length or the minimum length. In the same manner, you cannot find the maximum width or the minimum width. So this is the question in which the maximum and the minimum values cannot be calculated. The reason being, when the uncertainties are given and the original values are not given, then you cannot find the maximum and the minimum values. You will get some situations in which you'll be given with uncertainties and the quantities, and the actual quantities or the values will not be given. In such questions, maximum and minimum values cannot be calculated. Now, if you calculate a maximum, question is same. You need to calculate uncertainty in the area. But here the problem is you do not have L maximum and width maximum. Maximum length and maximum width is missing. So you cannot calculate the maximum value of the area. In the same manner, you cannot calculate the minimum value of the area. Now this formula delta A is equal to A maximum minus A minimum over 2 cannot be applied. You cannot apply this formula. The reason being, you cannot calculate the maximum and minimum values since the values are not given. Now in your syllabus, you will have two types of questions: when the values and uncertainties both are given, and the questions in which only uncertainties are given. So there are two types of questions. So in CAI syllabus, we'll get two types of situations. Number one, when values and uncertainties both are given. So one type of situation is when the values and uncertainties both are given. Then you can apply the formula uncertainty. Then you can apply the formula uncertainty is equal to maximum minus minimum over 2. Then this formula is applicable. However, when values of the quantities are missing and only uncertainties are given. So the type of questions in which you are only given with the values and uncertainties are not given, then you cannot apply the formula uncertainty is equal to maximum minus minimum over 2. This formula cannot be applied because you do not have any values and you cannot calculate the maximum and the minimum values. So in the second situation, this formula cannot be applied. On the previous page, this is according to number 1 and this is according to number 2. When the values and uncertainties both are given, you can apply the formula. When only the uncertainties are given and the values are missing, then you cannot apply the formula. That is example number 2. Now, one thing. What is the method of giving uncertainties in the questions? Sometimes uncertainties are given as uncertainties are given as so sometimes uncertainties are given as number 1 absolute uncertainty. Just for example, we have a quantity x, it would be given as x plus minus delta x. Let's suppose x is 10 and the uncertainty is 1. Now this uncertainty is called the absolute uncertainty. You can understand absolute uncertainty as this is the uncertainty in the actual data value. Just for example, in this case, actual value of x or value of x is 10. In a value of x is 10, that is 10. So we can say that when x is 10, the uncertainty is 1. Then this is principle for random uncertainties that if you increase the value, then the uncertain or decrease the value, the uncertainty is affected in the same manner. Just for example, fractional uncertainty. The concept of fractional uncertainty is that it is uncertainty if the data value is 1, uncertainty out of 1. Fractional uncertainty is uncertainty out of 1. How you will calculate that? You will divide delta x by x. Like in this example, it would be 1 over 10 and that would be 0.1. So we can say that this fractional uncertainty is basically dividing the uncertainty over value, and it is given as out of 1. this fractional uncertainty is uncertainty out of value 1. Then you can write uncertainty as percentage uncertainty. If you multiply fractional uncertainty by 100, then it will become percentage uncertainty. Just for example, delta x over x into 100. In this example, it would be 1 over 10 into 100. So it would be 10%. So we can also write uncertainty as percentage. So this is percentage uncertainty. Percentage uncertainty is uncertainty out of 100. If the data value is 100, then the amount of uncertainty would be the percentage uncertainty. So uncertainty can be written as absolute uncertainty, or it can be written as fractional uncertainty, or it could be written as percentage uncertainty. So you can write uncertainty as absolute. You can write uncertainty as absolute, or you can write it as fractional, or you can write uncertainty as percentage uncertainty. So these are the three methods by which you can write an uncertainty. An uncertainty can be written as absolute uncertainty, or it can be written as fractional uncertainty, or it can be written as percentage uncertainty. And when we get a problem, the problem is there when only uncertainties are given and the values are missing. Then you cannot use this formula maximum minus minimum over 2. And then you go with the shortcut formula. So I will say those formulae as shortcut formulae. However, in your syllabus, these formulae are called formulae for compounding uncertainties. So shortcut formulae are also called formulae for compounding uncertainties. Now calculating, basically it is calculating uncertainties in the answer using uncertainties in the data values, and you are only going to use uncertainties and not the original values. Now in this part, we'll write formulae for uncertainties in terms of uncertainties. Like we'll write the uncertainty of the answer in terms of uncertainties in the given values. Now let's start this. The first one is uncertainty in the answer of addition. From tomorrow we'll start from this point, and we have to make a formula for uncertainty in the answer of addition in terms of the uncertainties in the individual data values. Students, from tomorrow, will start from this point, inshallah. Take care. Khuda Hafiz.